Chapter 10, Section 5 talks about proportional changes on area and perimeter. So by the end of this lesson, you should be able to describe the effect on perimeter and area when one or more dimensions are changed, and then apply this relationship to problem solving. So let's just start with changing one dimension. So describe the effect on the change for this given area. So what if I multiply the height of the triangle by 6? So what we need to do first is figure out the original dimensions, what's going to happen, and then what happens when we multiply the height by 6. Since we're talking about area, we need to remember our area formula, which is 1/2 base times height. So with our original dimensions, the area is 1/2 times 12 times 5. Half of 12 is 6, and if you multiply it by 5, you get 30. But now if we multiply the height by 6, we have 1/2, our base is still 12, but our height is 5 times 6. And we can rewrite that as 30, or we can leave it like this. But you end up doing 6 times 30, which gives you 180 inches squared. So they want us to take a look at our original and somehow relate that to our changed, our multiply the height by 6. And if you notice, 30 times 6 also gives us 180. So if the height of the triangle is multiplied by 6, the area is multiplied by 6. So let's take a look at another shape. The diagonal SU of a kite with those vertices is multiplied by 1/3. So our original dimensions we need to find, and then we need to find out what happens when we take one of the diagonals and multiply it by 1/3. So the first thing we got to do is draw this and figure out our diagonals. So our first one is at 2, 2. So over 2, up 2 is R. S is at 4, 0. T is at 2, -2. And U is at -5, 0. So you can see this kite is what we have here. The original dimensions, remember the area of a kite is 1/2 diagonal 1 times diagonal 2. So 1/2, my first diagonal, it doesn't really matter which one we make the first diagonal, but is this distance here. It goes from -5 to +4, so it's a distance of 9. And this goes from -2 to +2, so it's a distance of 4. If we multiply those together, we get 18 inches squared. But now we want to do this over, and SU is going to be multiplied by 1/3. So SU is this guy right here. If we multiply that by 1/3, our new diagonal is only 3, 9 times 1/3, and we still got to multiply by 4. So you end up doing 2 times 3, which is 6 inches squared. If we start at 18 and we go to 6, we can quickly see that this is also multiplied by 1/3. So if diagonal 1 is multiplied by 1/3, the area is multiplied by 1/3 as well. Let's try another one. If the radius of a circle or the side length of a square is changed, the size of the entire figure changes proportionally. So let's talk about if we change 2 dimensions. Describe the effect of each change on the perimeter or circumference and the area of the given figures. So we got to talk about perimeter or circumference, if it's a circle, and area. So the base and the height of a rectangle with a base of 4 feet and height of 5 feet are both doubled. So my original rectangle has a base of 4 and a height of 5. We can find the area and we can find the perimeter. Area is pretty easy. It's just base times height. So we end up with 4 times 5, or 20. Perimeter, because it's a rectangle, we have the same thing on both sides. So you get 10 plus 8, or 18 feet. So now we want to double both of these. So now this is going to be 8 and this is going to be 10. So my area is still base times height, but this time it's 8 times 10, so it gives me 80. And my perimeter would be 20 plus 16, or 36. And then it wants us to describe the effect on this. So if we take a look from area to area, 20 to 80, we have to multiply by 4. And the way we can get 4 is because these are both doubled. So 2 times 2 gives us 4. The perimeter here to go from 18 to 36 is just times 2. It's just doubled. So let's take a look at a circle and see if we can notice any comparisons. So it says the radius of circle J is multiplied by 1/5. So the original dimensions, let's find circumference first. Remember, circumference is 2 pi r. So 2 pi times the radius of 10. The original circumference is 20 pi centimeters. Then the area is pi r squared. So pi times 10 squared gives me 100 pi centimeters squared. Now, if I take the radius and multiply by 1/5, my new radius is 1/5 of 10, or it's only 2. So I'm going to do the same thing. Plug in for my circumference, 2 pi times 2, which is 4 pi. And area, pi r squared, is pi times 2 squared. So we end up with 4 pi centimeters squared. And then let's compare them. To go from 20 to 4, we can multiply by 1/5. So it's the same as this guy here. But to go from 100 to 4, we have to multiply by 1/25, which is the same exact thing as 1/5 squared. Now, this is the same relationship as this over here. Multiply the perimeter by 2, but we multiplied the area by 2 squared. So this is something we did a long time ago, but it's good to see now that we know all these formulas for areas. So if you change a dimension, all dimensions are multiplied by whatever your change is. Perimeter or circumference changes by whatever the factor is. So if we make it twice as big, if we make it half as big. But then the area changes by the factor of whatever we're changing squared every single time. So what happens? Let's say we have a circle with a circumference of 32 pi inches. If the area is multiplied by 4, what happens to the radius? So we are given information that the circumference is 32 pi inches. We know that circumference is 2 pi times the radius. So we can use this to solve for what the radius would have to be. The pi's cross off, and 32 divided by 2 gives me 16. So that's what my radius has to be of the original. Now this is saying that the area is going to be multiplied by 4. I want to know what happens to the radius. So let's find the original area. Remember, area of a circle is pi r squared. So it's going to be pi times 16 squared. And since 16 squared is 256, this is 256 pi. And then we'll have inches squared on here. So this is the original. And now I want to multiply my area by 4. So area times 4. So 256 pi times 4 is 1,204 pi. Now, if this is my new area, 1,204 pi, I can solve for the new radius because I know area is just pi r squared. So then if I divide both sides by pi, those go away. And then I have to end up taking the square root of that 1024. And we get a radius of 32. So this is new. Now we got to compare these two things, original to new. And to go from 16 to 32, I have to multiply by 2. Area was multiplied by 4, so that means the radius is multiplied by 2. And that goes back to this. Whatever we changed it by, the area has to change by a factor of that squared. So if my area changed by 4, take the square root of it, that's how much my radius changed. If my area changed by 9, I'd take the square root of it, and 3 would be how much my radius changed. So the same thing happens with square. Let's say we have a square with a perimeter of 36 millimeters. So because it's a square, all the sides are exactly the same. So if we take 36 and divide it into 4, each side has to be 9. And then it's pretty quick to see that the area is 9 squared, or 81. So this is my original. And then it wants us to take this and it wants us to multiply it by 1/2. So my new area is going to be 81 cut in half. And let's leave it like this. So if I want to find how long the side lengths are, I know that the area of a square is just the side length squared. So we got to take the square root. So this will tell me the side length is the square root of 81 divided by the square root of 2. We know the square root of 81 is 9. And the square root of 2 we can't do anything with. So if we want to compare these two numbers, and this one's a little harder to see, but we end up multiplying by 1 over the square root of 2. 9 was my original side length. Sorry, we're not comparing these, we're comparing these. 9 was my original side length, and then my new one is 9 divided by the square root of 2. And if you stop and think about it again, if I change my area by 1/2, that means my sides had to change by the square root of that. And if you take the square root of 1/2, it eventually simplifies to 1 over the square root of 2. So those last two problems were what this was talking about. This stuff's a little easier, but we will do lots of practice on both of them tomorrow in class. So write down any questions you have and we can go over them then. Enjoy your night.